Thanks so much for this kind invitation to talk to this fourth Brazilian Symposium on conservation biology. My contribution today is a simple one. I want to examine the question of how successful our efforts to conserve the rest of life on Earth. I want to start on the other side of the world, in the Philippines, and specifically an island in the central Philippines of about 5,000 square kilometers called Cebu. This map is from Protected Planet, which is a data system I'll talk about more later. The area outlined in red is Central Cebu National Park, which was established in 1936. As on tropical forest islands elsewhere, tremendous unique biodiversity has evolved on Cebu, with numerous endemic species, including this Cebu four-coloured flower pecker. However, Cebu has been massively deforested over the last century. As a result, this famous paper, published in the Orc in 1959, proclaimed that all but one of its endemic forms, as well as several other forest species, may have disappeared. On Cebu, at least, it doesn't sound as if conservation has been working. Now let's zoom up to the global view. What do nation states and intergovernmental processes have to say about biodiversity and conservation? Recently, answers to this have become quite compelling. For example, in 2010, most of the world's governments agreed to the 2011 to 2020 Strategic Plan for Biodiversity and its 20 ACHI targets, the most powerful set of commitments to environmental sustainability that the planet has ever had. Examples include ACHI Target 11, which aims to establish protected areas to safeguard areas of particular importance for biodiversity, and Target 12, which aims to stop human-caused extinctions. In September 2015, these kind of commitments were scaled up to the entire planetary enterprise, bringing social and economic dimensions of sustainability together with environmental ones, with the agreement of the 17 United Nations Sustainable Development Goals and its 169 associated targets. These include Goal 14 for life in the sea and 15 for life on land. However, it's probably wise that we retain a bit of skepticism regarding international commitments. At very least, it's clear that the moment of truth comes with their implementation. What do they mean for biodiversity and for conservation in the real world? For tracking the Strategic Plan for Biodiversity 2011 to 2020, it's useful to organise indicators according to a pressure state response framework, expanded to include a component to track the benefits which biodiversity conservation provides to people. To consider my question of what effects conservation actions are having on the ground and in the water, I'll focus on indicators in two of these components, the first of which measures the state of biodiversity. The specific state indicator that I'll discuss is the Red List Index, an indicator of genuine changes in extinction risk across entire groups of species. This is based on the IUCN Red List of threatened species, which dates back more than 50 years and is convened by IUCN's Species Survival Commission. Now, over the last decade, several major changes have been introduced into the Red List process, which have been crucial in allowing the derivation of Red List indices. First, historically, Red List assessments were based on expert opinion, literally by asking experts how threatened a species was. At the Road to Extinction conference in 1984, it was realized that this approach was insufficient to allow comparisons between species assessors, groups, regions, countries, or time periods. Based on this, the Species Survival Commission triggered a process of development of quantitative categories and criteria. first published in 1991 by Georgina Mace and Russ Landy. This then went through extensive refinement and was eventually approved by IUCN's Council in 2001. These categories and criteria are enduring. They remain in force today. The second major change is that the Red List assessments have shifted from being one-off assessments of species considered a priori to be threatened to repeat assessments of all species within given taxonomic groups, including those assessed as least concern and data deficient. Global assessments have now been published 6 times for all birds by BirdLife International, and twice for all amphibians, mammals, corals, cycads, and other groups. These repeat assessments of every species in particular taxonomic groups allow the calculation of Red List indices to tell us how fast the aggregate extinction risk facing an entire species group is changing. Here then are some examples of Red List indices from a latest report against the Millennium Development Goals. These span 5 taxonomic groups, with the last 35 years shown on the x-axis. The position on the y-axis shows the aggregate extinction risk facing a given species group at a given point in time, with 0 indicating that all species are extinct, and 1 that all species are least concern. And the slopes therefore tell us how fast aggregate extinction risk is changing. 2 major points stand out. The first is that aggregate extinction risk is increasing for all 5 taxonomic groups considered to date. The second is that these results are quite variable between taxa. Some taxonomic groups, notably cycads and amphibians, are much more threatened than others, and there is similar variability among rates of change, with extinction risk facing coral species increasing fastest. A third major change to the Red List process over recent years has been the addition of required documentation over and above assessment of extinction risk. This documentation includes information on habitats, threats, and critically spatial data, which allows us to disaggregate the Red List index geographically. This reveals that, in addition to being variable among taxa, the Red List index is also very variable over space. Here we disaggregated it among countries, with darker purple colours showing more rapid slides of mammal, bird and amphibian species towards extinction. The countries with rapid losses stand out: the Andean nations, Mexico, the USA, China, Indonesia and Australia. Let me switch over to consider indicators under another component of the indicator framework, this time to look at responses in policy and practice established to stem the loss of biodiversity. Now, the longest established mechanism for conserving biodiversity is the establishment of protected areas. The world has set up more than 200,000 such protected areas. These are documented by UN mandate in the United Nations list of protected areas, which is served through a system called Protected Planet by IUCN and its World Commission on Protected Areas, and UNEP and its World Conservation Monitoring Centre. The system operates according to IUCN standards for the definition of protected areas and categorization of their management, spanning 7 categories from strict protection to multiple use, and governance, spanning public, private, local and indigenous, and mixed governance arrangements. Now, simply looking at the coverage of land area and sea area by protected areas, a quite positive picture emerges. There have been huge efforts to increase the size of the protected area estate, with the coverage of protected areas doubling to cover 1/6 of the world's land area over the last 25 years, and increasing from 1% to 8% coverage in the sea. However, considering protected area coverage alone misses the fundamental point that the objective of protected areas is to safeguard biodiversity, not merely to cover area. If biodiversity was randomly or evenly distributed over the planet's surface, this would be okay, but it's not. This has been recognized for many decades, of course, and great efforts have been undertaken to identify those places which contribute significantly to the global persistence of biodiversity. The best example is for birds, for which the BirdLife International Partnership of national organizations around the world have identified over 12,000 important bird and biodiversity areas, following consistent criteria and thresholds. Similar approaches have been developed for amphibians, for butterflies, for plants, for freshwater and marine biodiversity. One downside of this proliferation of approaches to identifying important sites for different elements of biodiversity has been some level of policy confusion. Decision makers often don't understand why, if they've already established protected areas to protect important sites for birds, they should then add new ones for butterflies or other species groups. To avoid such confusion, in 2004, IUCN's members asked the Union to undertake a broad consultation to establish standards for the identification of key biodiversity areas as sites contributing significantly to the global persistence of biodiversity, spanning all elements of biodiversity. This standard was approved by IUCN's Council last year at the World Conservation Congress last September, and a dozen organizations launched a Key Biodiversity Areas Partnership to support the implementation of this new standard. So what's the implication of the identification of key biodiversity areas, like important bird and biodiversity areas, for tracking conservation actions via protected area indicators? If we look at coverage of these key biodiversity areas as a proportion of total protected area, we find a rather disturbing result. Over the last 5 decades, establishment of protected areas to safeguard sites contributing significantly to the global persistence of biodiversity has been slower than the rate of expansion of protected areas overall. In other words, protected area coverage has expanded disproportionately fast in places unimportant for biodiversity. This is a direct consequence of the unfortunate measure of conservation response as protected area coverage of area. It provides an incentive to establish protected areas in places that are cheap and easy to protect, and therefore generally remote and contribute little to safeguarding biodiversity. So the picture emerging from consideration of indicators towards global sustainability commitments is a pretty bleak one. Indicators of the state of biodiversity are showing severe declines, and response indicators such as protected area coverage show that many conservation responses are not well formulated, and the coverage of protected areas of sites which actually need protection is in fact decreasing. Maybe conservation is failing. Maybe environmental sustainability is an unattainable goal. I don't think so. For the rest of my talk, I want to argue that these indicators only tell us part of the story and must be complemented by a consideration of what would have happened in the absence of actions to answer the question of whether conservation works in an informed way. Okay, so imagine we have our baseline, let's say the Red List Index in 1980. The indicators we've shown so far show how it's changed, given whatever policies we've had on, up until the time of our evaluation today. However, we need to complement this by understanding the counterfactual, what would have happened in the absence of these interventions, that is a policy-off scenario. The difference between these is the actual impact of the actions in question. Using such counterfactual techniques, of course, has its roots in null model formulation in pure science and is widely used in medicine and other disciplines, but has only recently been introduced into conservation. How can we derive counterfactuals for what would have happened in the absence of conservation for, let's say, the Red List Index? To understand the first step of how this can be done, let's go back to the map of the Red List Index. In addition to all that purple showing various rates of decline towards extinction, we can also see some green areas. These are places where the Red List Index is improving. Aggregate species extinction risk is being reduced. Many of these are at sea and reflect reduced pressure on marine mammals subsequent to the cessation of commercial whaling and sealing. But some are also terrestrial, countries shown here with circles: the Seychelles, Mauritius, Tonga, the Cook Islands, and Fiji. So to derive a first simple counterfactual for the Red List Index, we can simply exclude those species for which extinction risk has decreased as a result of conservation action. Here are those red list plots I showed earlier. The grey shading indicates confidence intervals, generated based on the data deficient category, by the way. Mike Hoffman and colleagues then excluded from the calculation all species that had undergone reduction in extinction risk as a result of conservation action over the last 3 decades. The resulting counterfactual is shown with the red lines. It reveals that while amphibian conservation has yet to make a significant difference, for both birds and mammals, conservation had the impact of slowing the rate at which species are sliding towards extinction by about 20%. However, Hoffman et al. Was still a heavily conservative estimate of conservation impact, because it did not consider cases where pressures were increasing, but extinction risk did not increase due to effective conservation action. To get at this, Hoffman et al. Established scenarios for ungulate species, which reset the clock to 1996, and then projected extinction risk forward by assuming that no conservation actions had been implemented since then. Their results were dramatic. Here, the best estimate of the counterfactual was no less than 8 times higher than the actual change. Here's an example. The Javan rhinoceros is currently critically endangered, but would certainly be extinct now were it not for the great efforts underway to safeguard its last holdout, the key biodiversity area of Ujung Kulon in West Java. Thus, for ungulates at least, the impact of conservation action has been to slow the rate at which species are sliding towards extinction by an order of magnitude. Here's a counterfactual view of the genuine impacts of protected areas, examining their impact in reducing species extinction risk. Butchart et al. Considered all species triggering the identification of key biodiversity areas, and compared changes in extinction risk over the last 3 decades for poorly versus well-conserved species. For both important bird and biodiversity areas, shown here, and for Alliance for Zero Extinction sites, another set of key biodiversity areas for highly threatened species, the rate at which species have been sliding towards extinction is twice as high for species for which important sites are poorly protected as it is for those with important sites that are well protected. Moving on to the final part of my talk, I want to say a few words about an emerging systematic assessment that we have underway of the genuine impact of conservation action. As a rapidly growing field, the number of studies and papers published in conservation increases every year. But we're also seeing that the proportion of these studies which are assessing the impact of different conservation actions is also increasing, a really encouraging sign. My colleague Penny Langhammer is in the process of leading an analysis of the genuine impact of conservation based on this growing volume of literature. Specifically, she led a literature review using a standardized search protocol and set of keywords through the Web of Science, with expert reviewers focusing on different kinds of interventions to identify studies evaluating the impact of conservation actions compared to those outcomes expected in the absence of conservation. Langhammer structured the review to respond directly to a key set of policy mechanisms, including the focal areas of the Global Environment Facility's 6th Programme, the ACHI targets of the Strategic Plan for Biodiversity 2011 to 2020, the Sustainable Development Goals, and the other Rio Conventions and biodiversity-related conventions. The review carefully delimited its scope to exclude climate change mitigation and also benefits to human well-being and the impacts of actions to address the indirect drivers of environmental degradation and the enabling conditions for conservation action. Our reviewers evaluated a total of 17,367 papers, of which just 3% met our criteria for inclusion. A low hit rate like this is desirable in such a systematic review, in that it minimizes the omission error rate. We're not missing papers that should be included. Most of the work to evaluate the impact of conservation is concentrated, in fact, on just 3 classes of actions: establishment and management of protected areas, both terrestrial and marine, eradication and control of invasive alien species, and sustainable management of terrestrial ecosystems under agriculture. These 3 classes comprised 70% of all the studies in our review. There's a notable lack of studies around actions to reduce the impacts of climate change and pollution on nature, other than for the specific case of organic agriculture. We extracted data for each paper on the type of response, the dependent variable, the overall impact, that is positive or no difference or negative or mixed, the type of counterfactual, the governance arrangements, the project time frame, the geographic region, and the cost of the intervention. The majority of the studies reviewed were conducted in Western Europe, North America, Australia, and New Zealand, while Africa, Asia Pacific, and Latin America together comprised just 1/3 of the studies. This is likely expected, given that conservation effort globally and investment globally is concentrated in those regions. Plus, we conducted the review in English. Here's how the measures of genuine impact stacked up across the studies. Overall, we found that 70% of studies showed a positive impact of conservation action. Another 8% showed mixed results, while just 8% showed negative impacts of conservation actions. Nearly 3/4 of conservation interventions have a genuine positive impact compared to what would have happened in the absence of those interventions. I want to conclude by taking you back to Cebu to give a real-world example of how much worse things would be in the absence of conservation efforts. In 1993, the Cebu flowerpecker was rediscovered in central Cebu National Park, and it's now been found at a second site shown here called Nug-As. Over the last decade, the Philippines Biodiversity Conservation Foundation has been working here with local government support to employ local communities to protect the remaining forest and reforest the degraded lands around them with native trees. It's a slow process, and the fate of the Cebu flowerpecker and many other species still hangs in the balance. But we can be sure that conservation has had a great impact. These species would very likely be extinct without these efforts, fulfilling the prophecy made all the way back in 1959. I'll leave you with a call to arms for the development of counterfactual scenarios representing an exciting frontier of conservation research. So please consider it as you explore the applied implications of your own work. The overall message here that I'd like you to take home from my talk is that while the world is still far from achieving absolute targets for conservation, the Sustainable Development Goals, the ACHI targets, the state of nature would be far worse were it not for conservation efforts to date. Conservation works. We just need much more of it. Thank you very much indeed.